Here is a review on naming. So this is Mrs. Berger, and I want you to follow along on this note sheet. So one thing that I want you to do as I'm going through this is pay attention to what I have written right here. That I want you to put these things on your periodic table. So Ag, silver, is always a +1 charge. Cadmium, Cd, is always a +2. Zinc, Zn, is a +2. Gallium is a +3. And aluminum is a +3 as well. Okay, so fill those in. So those charges will never change. Okay, they're always going to be that charge. So this is meant to be a review of naming. So we started naming ionic bonds very simply with things from the main group elements, so main group cations, so the positive things, and main group anions, the negative things. And the first word, the cation, its name never changes. It's just whatever the first word is. And the second word, okay, the anion, its name does change. The ending changes to "ide." So MgBr2, magnesium, its name doesn't change, but instead of bromine, it becomes bromide. Okay, next we have beryllium and arsenic. So it will be beryllium, arsenide. Next we have potassium is K, N is nitrogen, potassium nitride. Next we have strontium and selenium. Selenium doesn't follow the normal naming convention. It just becomes strontium selenide. Okay, here we have silver. Silver I shared with you just a couple of minutes ago that silver is always a +1, so we don't need to use any kind of Roman numerals with it. We just need to say this is silver and chlorine, so it's silver chloride. So its charge is known just as well as something in group 1 or group 2. Okay, here we have aluminum. Aluminum also has a known charge, so this will be aluminum with oxygen, aluminum oxide. Okay. Now, going from name to formula, we have to make sure that we're writing down the symbol of each element, but also their charge, and we're going to balance their charges in order to get our formulas. So sodium oxide, I know sodium is a +1, oxygen's a -2. So in order to balance out that -2, we're going to need 2 sodium. So Na2O. Strontium bromide, strontium is a +2, bromine is a -1. So it'll be SrBr2. Rubidium nitride. So rubidium is a +1. Nitrogen is a -3. So it will take 3 rubidiums to balance out the nitrogen. Beryllium arsenide. Beryllium is a +2. Arsenic is a -3. So this is where we need to meet up at 6 because we have to have the same number of electrons given as taken. So it will be Be3As2. Next we have radium iodide. So radium is A+2. Iodine's a -1. So we need 2 iodines, RaI2. Okay. Aluminum fluoride. So we know aluminum, because we just wrote it on our periodic tables, is a +3, and fluorine is a -1. So it's going to take 3 fluorines to balance out that aluminum. So AlF3. Zinc oxide. Zinc oxide is used in sunblocks. So it will block out the sun because it's got that like solid color. So sometimes you'll see lifeguards with that on their noses, and they'll see like the big white block of a nose. So zinc, we know its charge is +2. Oxygen's a -2. So the formula is just ZnO. Next we have gallium sulfide. Gallium is a +3. Sulfur is a -2. So we're going to need 2 galliums and 3 sulfurs. Okay. Next we're going to use our polyatomic sheet. Okay. So you don't have to change anything about the names using a polyatomic. Now, how do you know the difference between a polyatomic and a regular thing off the periodic table? Most polyatomics end in ate or ite. Okay, there are only a couple of them that have exceptions to this rule, and those are cyanide and hydroxide. Okay. Everything else, if it ends in "ide," is something off the periodic table. Okay. Now, there's only one positive polyatomic, which is ammonium. So ammonium can be put with a negative polyatomic, like nitrate, so it can be ammonium nitrate, or it can be put with an anion off the periodic table, like fluorine, so ammonium fluoride. Okay. So here we have magnesium with nitrate. Oops, scooted me up. Magnesium, nitrate. And just going to take some getting used to get used to using that list. Here we have cesium. And this whole thing is called arsenate. Here we have ammonium and phosphate. Ammonium phosphate. So 2 polyatomics together. We have silver. Silver. Chromate. Nope, that's not chromate. Oxalate. Here we have ammonium with something right off the periodic table. So it will be ammonium. Sulfur becomes sulfide. Okay. So going the other way. Really not too difficult. Sodium phosphate. So we're going to write down, we have a sodium, which is a +1. Phosphate. I look at my list. I see that phosphate is this. It's a -3. So to balance out the charges, I'm going to need 3 sodiums, Na3P. Na3PO4. Okay, I do not need parentheses around my phosphate because there's just one of them. Okay, calcium arsenate. So calcium is a +2 charge. Arsenate is AsO4 with a -3. So this is where I'm going to need to meet at 6. Okay, 6 electrons given, 6 electrons taken. So Ca3, I need to put parentheses around my arsenate, AsO4 2. potassium oxalate. So it's K is a +1. Oxalate is this, C2O4 minus 2. So since K is a +1, oxalate's a -2, I'm going to need 2 Ks, K2, C2O4. Aluminum dichromate. Aluminum is a +3. Dichromate, Cr2O7 with a -2 charge. Okay, so here we have to meet at 6 again. So I'm going to need 2 aluminums and 3 dichromates. Next, I've got ammonium carbonate. Ammonium's a polyatomic, NH4 with a +1. Carbonate, CO3 with a -2. So I'm going to need 2 of those ammoniums. So I'm going to put my ammonium, NH4, in parentheses, CO3. Okay. Next, I've got cadmium bromate. So cadmium is a +2. Bromate, BrO3 -1. Okay, so cadmium, I'm going to need just 1, and I'm going to need 2 bromates, BrO3, 2. Okay, so transition metals. Transition metals are tricky. Now, one thing I want to point out to you is that transition metals include all of the elements from after group 2. So let me get my highlighter here. All elements from after group 2 to the metalloids. Okay, so if you're looking at the periodic table, get this pencil. So looking at the periodic table, and if you've got the metalloids here, I mean, obviously it's not drawn to scale, but the transition metals don't just include the D block elements. It actually includes everything up until the metalloids, okay? So things like indium, tin, which is SN, PB, which is lead, Vi, which is bismuth. Those are transition metals, and those have variable charges. So you will need a Roman numeral with those, okay? So going from name to formula, you're going to use the Roman numeral as the charge of your cation and balance the charges with the number of anions and the charge of the anion. So let's do an example because that sounded a little confusing. So this is telling me I have titanium, and the charge on my titanium is a +3. And it's bonded to oxygen. Oxygen is a -2. Okay, so now to balance these charges out, I need to meet at 6. So that means I'm going to need 2 titaniums to get to a +6 and 3 oxygens to get to a -6. So now their charges are balanced out. Next we have cobalt 2 chloride. Well, this is telling me I've got cobalt with a +2 charge and chlorine with a -1 charge. It's always known to be -1. Okay, since my cobalt has a +2 charge and my chlorine has a -1 charge, it's going to take 2 chlorines to balance out my cobalt. Okay, the next problem we have has a transition metal and a polyatomic. So it's like a mixed bag here. So oxalate, first of all, is C2O4 -2. That's from my polyatomic sheet. This is telling me we've got platinum, and my platinum has a +3 charge. So to balance these out, I'm going to need to meet at 6 again. Okay, so PT3 C2O4. I don't need 3 platinums, Mrs. Berger. I just need 2. There we go. Okay. Manganese V means 5. Manganese 5 oxide. So manganese's formula is Mn. This is telling me it's a +5. And oxygen is a -2. So to get these to meet up, I'm going to need to meet at 10. Okay, so I'm going to need 2 manganeses and 5 oxygens to meet up at 10. Okay. 5, you might get as high as 7, but very rarely get above 5. Okay, next we have gold 3 nitrate. So that is the polyatomic nitrate. NO3 with a -1. This is gold. Gold is Au. It's got a +3 charge. So I'm going to need 3 nitrates. Au, then O3, 3. Next we have iridium 2 chlorate. So iridium with a +2 charge. Chlorate, ClO3 -1 from the polyatomic sheet. So this is going to need 2 chlorates. So IR, ClO3, 2. Okay. So next, going from formula to name. So just a reminder, even though zinc, cadmium, aluminum, gallium, silver, they're all technically transition metals, they have a known charge, so they do not need Roman numerals. Okay? When you are providing a name to something that is a transition metal, you are not putting the number of them in the parentheses. The only thing that is going in parentheses is the charge of your cation. So the way we solve these is we figure out the charge on our anion, and then based on what we know about our anion, we can go back and solve for the charge on our cation. So it's like, let's take a look at this first one. So PbO. So I'm going to split it in half. So oxygen, there is 1 oxygen, and each oxygen's a -2. So that gets me a -2 on this side. So this side needs to be a +2. And there's 1 lead that's going to give me that +2. So that means my lead needs to be a +2 charge. So lead 2 oxide. Okay, because my oxygen is a -2. And I have 1 Pb, so that means it has to be a +2 to cancel it out. Okay, let's take a look over here. PbO2. Well, here I have 2 oxygens. So it's 2 times a -2 over here. But it's giving me a -4. And I now have to cancel out a +4. And I only have 1 lead to do that with. Okay, so it's lead 4 oxide. Okay, now here we've got more than 1 lead. So let's take a look at this now. Pb2O. So we have 1 oxygen that is a -2 charge. So it's a -2 from this side. This side too, we have 2 Pb's that are adding up to give me a +2. So that means that each Pb must be a +1. So my name here is lead 1 oxide, because I have 2 Pb's, Pb +1, Pb +1, and 1 oxygen, which is a -2. So on my cation side, I have a +2 charge. On my anion side, I have a -2 charge. Here I have iron and a nitrate, and we have 2 nitrates. So we have 2 nitrates, and each nitrate is a -1. I can tell that by looking at my polyatomic sheet. It's a -2 on this side. Okay, so that means on this side, my one iron has to equal out a +2. So this is going to be iron 2 nitrate. Here we have iron and oxygen. Draw a line here. So we have 3 oxygens, and each oxygen is a -2. So that gets me a -6. So on this side, it has to be a +6. I have 2 irons equaling that +6. So that means that each iron has to be a +3. So this will be iron 3 oxide. Okay. Lastly, I've got chromate here. So chromate, each chromate's a -2, and we have 2 of them here. So this side is giving me a -4. This side has to be a +4. Okay, so this would be 10, 4 chromate. I wonder what 10-1 chromate would look like. So let's go the opposite way. 10-1 chromate. Well, chromate is CrO4 -2. This is telling me I have an SN with a +1 charge. So we would need 2 tins. SN2 CrO4. Okay. Here I have a snapshot of a worksheet that you're going to be doing in a few minutes. So I want to give you a strategy here when you're looking at these. Now, the ones that are going name to formula, you don't necessarily need to be too concerned about those. The only thing that I would caution you on is to, like, for example, copper 1 arsenide. I want you to maybe underline the endings and know that ides are from the periodic table, where 8s and ites come from the polyatomic sheet. Okay, so this would be like a polyatomic. This is a polyatomic, includes a polyatomic. So you're not going to write, for example, a lot of times people will see this and want to use like sulfur. Okay, now if you wrote the PA there, you're going to know, no, I actually just need to go to the periodic table. Not the periodic. You need to go to the polyatomic sheet because it ends in 8. Okay. On the other side, going from formula to name, I want you guys to do this. Okay, so I want you to put an asterisk next to ones that you know are going to need a Roman numeral, so that later on when you go to do the actual worksheet to solve it, you don't forget to do a Roman numeral, because that happens a lot. So chromium is in the middle in the periodic table. It's in the D block, so I'm going to put an asterisk here. Aluminum, nope, I know it's always a +3. Lead, PB, that's going to need a Roman numeral. Okay. Lithium does not need a Roman numeral. Titanium does. Cobalt does. Magnesium does not. Gallium does not. Silver does not. Okay. And that is it. If you are having more difficulties, see the videos spreadsheet that I posted on Google Classroom. There's more information there about naming.